Welcome back, everyone. This is APNIC 50 Technical Session 2. My name is Anna from APNIC, and I will be your MC for this session. For those who are joining us for the first time, hi. Before I give the mic to our moderator, just a friendly reminder that be mindful of the Code of Conduct, which is published at the conference website and in the chat box. If you want to ask a question or write a comment, you can either use the raise hand function in Zoom, and you will join the queue for voice question, or use the Q&A button in Zoom for text. And I will read your question or comment to the speaker. And for those who have already taken their photos while attending APNIC 50, let's have a bit of fun and post them on Facebook or Twitter using the hashtag APNIC 50. I am now going to hand over the mic to our moderator, Warren Finch from APNIC. Warren?
Thank you, Anna. Good afternoon, good morning, hello everyone to this technical session 2. We have a focus on domain name services. We're going to start with our first presenter, Han Zhang. His presentation is based on DNS OARC 31, and he wrote a blog for APNIC earlier this year. It's in regards to the domain name system security extensions, and it's a suite of specifications for securing certain kinds of information provided by the DNS. Although it's relatively straightforward for any sized enterprise to deploy, there are challenges, especially for enterprises that have large zones with frequently changing records. So in this presentation, he will cover his experience at Salesforce from deploying DNSSEC on a very large dynamic live production zones, hoping these will help other organizations when they take this road. Han, over to you.
Thank you for the introduction, Warren. Now I'm going to share my screen. Oops. Can you see my screen?
Yes, we can see your screen.
Okay, cool. Thanks. So today I'm going to talk about deploying DNSSEC in large enterprise. And my talk will cover 3 parts, some introduction, and then I'm going to cover some challenges when we deploy the DNSSEC and how we handle these challenges. And at the last, I'm going to share some takeaways. So DNSSEC is DNS security extensions. So basically, it verifies the DNS responses by using public key. So for example, if you queried IP addresses for www.example.com, you can verify the return IP addresses are authenticated. And this DNSSEC helps detect different types of DNS attacks, including spoofing, misredirection, cache poisoning, and some other attacks. So there are some reasons why a large enterprise want to deploy DNSSEC. So the first reason is compliance. For example, at US, we had FedRAMP compliance, which requires the DNSSEC. And I believe there are some other regulations in the other countries. And actually, ICANN also advised, so I should just deploy DNSSEC. And another reason to deploy DNSSEC is to get more trust from the customers, because the customers can verify the returned DNS responses are authenticated. But there are some trade-offs between separating small namespace for regulated groups or applying DNSSEC for all. For example, like zone management and key management and some other things. So at Salesforce, we decided to apply DNSSEC for all of them. I also want to share some characteristics for our enterprise zones. That's because some of the decisions we made are based on these characteristics of our zones. So at Salesforce, we outsource our DNS services to third-party DNS vendors to get sufficient authoritative footprint. So that means our DNS services will be hosted, will be available globally, and all the customers can query our zones and get pretty good performance. And we also use multiple DNS providers for resilience. So that means our DNS service can survive if a single DNS provider is completely down. Some of our zones are very dynamic. So we have up to 1 million changes per day. So it's about 7 changes per minute And this dynamic zone are not unique to us, I think. For example, some web hosting companies also have these very dynamic zones. And these dynamic zones, the changes, DNS changes, can cause some update propagation delays. So these propagation delays means when we make DNS changes by using the REST API calls, it takes time to propagate the DNS changes to all the name servers globally. So another feature of our zones is our customer-facing zones are very, very large, even before we applied DNSSEC. So these two features introduce some challenges, and I will cover them in the next few slides. So the first challenge we had is about the preparation, even before we started deploying DNSSEC. So as I mentioned earlier, we use third-party DNS providers for our DNS service. So the first challenge, or the first question we had is which DNS provider we should use. So my colleague Avi and Shuma has done some great work to compare different DNS providers from different perspectives. For example, the zone setting algorithms, NSEC support, NSEC 3 support, or key rollover support, and some other criteria. So please go to their talk for the details. But the conclusion we had is there's no single DNS provider that satisfies all of our requirements, our key requirements. So that's one of the reasons why we had to migrate some of our zones from one vendor to another. And I will cover our zone migration in the next few slides. So the second challenge we had is which DNSSEC models we should apply. As I mentioned earlier, we use multiple DNS providers for our DNS services. And the ideal model to apply the DNSSEC on these multiple DNS providers is called multi-signer DNSSEC models. And that is also introduced by my colleague Schumann. But when we deployed DNSSEC, there were not enough DNS providers that supported these features. So we had to apply the following two DNSSEC models. But one question is why we needed to apply two DNSSEC models, why we could not just apply one of them. So the reason is, so at Salesforce, we have many zones, and they have different features, different characteristics, like the zone sizes, how dynamic the zones are, the key management policies, and how critical these zones are to our business. So we categorized our zones into two groups, and then we applied two DNSSEC models on these two different groups. The first DNSSEC model we applied is hidden setting primary model, which is shown in this figure. So on the left side is the zone update originators. So basically it's our Salesforce code base. So we have many applications that send DNS updates. And in the middle is the REST API service and the hidden primary our team built. So the REST API service received the input from the zone DNS originators, and then it sends the updates to the hidden primary by using the dynamic updates. And from there, our hidden primary signs the zones and then do the zone transfers of the signed copy of the zones to two DNS providers. And from there, our customers can query our zones and see the DNSSEC. The second DNSSEC model we applied is a third-party setting vendor model. So in this case, the left side is the same. It is the zone update originators. But the difference here is these applications directly send the DNS updates to third-party REST API services. And this REST API service sends the DNS updates to two different infrastructures from the same DNS provider. And these two infrastructures do the online signing. And our customers can query our zones from there. So these two separate infrastructures they're using different IP addresses, and they're using different routing policies and some other different things. So in that case, although these two infrastructures are from the same DNS vendor, we still consider we have two separate DNS providers. So we still have our DNS service resilience. So as I mentioned earlier, there is no single DNS vendor that satisfies all of our requirements. And we had to categorize our zones into two groups and then applied two different types of DNSSEC models. So because of these reasons, we had to migrate some of our zones from one vendor to another. So this zone migration sounds very simple, right? So it basically requires two changes. One is we need to make some code change in the zone update originators to let Nate send DNS updates to the new vendor instead of to the old vendor. And another change is we have to change the DNS records for the zone at the parent, for example, at .com. So this sounds very simple, but when we do this, it will be a disaster for our business. The reason is because the code release cadency and the TTL for the DNS records. So these two changes cannot happen at exactly the same time. So if we do this simple migration, both of the provisioning and resolution will be broken. So the REST API calls will not work and the customers will not see the correct answers, or they will see the outdated responses. So our solution is we did multiple step migration. And I'm not going to cover the details here due to the time limit, but we covered these details in our APNIC blog. So when we did zone migration, we also found another challenge for the delegation of the child and the parent zone. So the issue is if both the child zone and the parent zone are on the same provider, and only the child zone is migrated, then the old provider still serve our child zone after the NS change. So I think the reason is if both the child zone and the parent zone, they are both in a database on the name servers, the name server will just ignore the delegation and then answer the queries for the child zone. And our solution is we migrated both of the child zone and the parent zone at the same time, because it introduces no downtime, which is very critical to us. And there's no impact on provisioning. So our REST API service can still send DNS updates, which is also critical to our business. But the shortcoming here is just in case we need to roll back our change, we have to change both of the parent zone and child zone's DNS records at the same time. So now I'm going to cover some DNSSEC specific changes. So the first challenge here, the DNSSEC specific challenge we have is for the setting jittering. So when the zone is assigned by DNSSEC, when the RRC expires, they need to be resigned periodically. But if all of the RRC expires at the same time, that means the entire zone will need to be resigned, and there will be a lot of AXFRs, and that increases the load on the secondaries. So to solve this problem, our stack vendor created a strong jittering for us. So that means instead of letting all of the RRC expire at the same time, the expiration time will be distributed. And so these two figures show the RRC expiration time distributions before we apply strong jittering and after. So from this figure, we can see before we apply the strong jittering, almost all of the RRC will expire at the same time. And after we apply it, it's more distributed, it's more flat. So that helps reduce the load of the AXFRs to the secondaries. We also found the NSEC 3 support can be awkward to use and it's hard to debug. So for example, we discovered a bug that returned incorrect negative proofs. We also found one public recursive was not able to return the responses for records. And although that records have some complex configurations. It's kind of a corner case. So they CNAMEs cross zone boundaries, and there were some wildcard, but still this public recursive was not able to properly return the responses for DNSSEC. So as we applied hidden primary master, adding a zone and assigning this zone can be complex. And our recommendation is to add as much automation as possible, because it helps avoid human errors. And we always do a pre-delegation testing before any production changes, like changing NS records or adding DS record before we do any production changes. And we use DSVs for our pre-delegation testing. It's very helpful, super helpful. So the last challenge we have is the DNSSEC on hardware load balancers. So we do have some leaf zones hosted on the i5 GTMs. And we had some challenges to deploy these leaf zones on i5 GTMs. And one example is the signature inception offside was missing. And we had to work with the i5 engineers for hard fix and solve this problem. So another example is we have the leaf zones on two i5 GTMs in two data centers. It's kind of deploying DNSSEC in active mode. So that means some configurations need to be changed between these two i5 GTMs. And there were some problems by doing this. So we also worked with the i5 engineers to get this done. And there are some other challenges to deploy this on i5 GTMs. And my colleague Neda has given a great talk about the challenges on i5 GTMs. And please go to her talk for more details. So now I'm going to share some takeaways. So as we can see in this talk, there are some challenges and even some surprises when we deploy DNSSEC in large enterprise for large dynamic and production zones. But we can also see this can be done. When we deploy DNSSEC, it requires some DNSSEC specific tasks, but it also requires some preparation, migrations, testing and monitoring, which I don't have enough time to cover here. So we also see some DNSSEC burden from old standards, and that is also tough, like the delegation issues and XFRs issues we have seen, but all this is different from the burden from the new standards. And at the last, I'm going to thank engineers and also the product managers from our DNS providers. And this talk is teamwork. So everyone on our team is an author for this talk. And now I'm going to, I'm open to the questions.
Thank you so much, Han, for your presentation. We are now open for questions. As a reminder, you can either raise your hand in Zoom or you can type your question in the Q&A. Okay, we have one from Tri Nguyen Van. Tri, we will unmute you and you can go ahead and ask your question. Go ahead, Tri.
Hello.
Yes, go ahead. We can hear you.
Yeah, hi, Anna. Hello, my name is Tri. I'm a DNS administrator from VNLink of Vietnam. And thank you for sharing the slide. And I have some questions for you, Mr. Han. The question one is, during the DNSSEC signing and data synchronization is very important in DNSSEC deployment of DNS providers. So can you share the processes as well as software tool that can monitor or track DNSSEC data signing and synchronize data to ensure accuracy and integrity?
Okay, yep, that's a great question. I think,
Yeah.
yeah, thank you for the question. I think you're asking some monitoring, some tools can be used to monitor the status of the DNSSEC, right? So yeah, so we do have some contents for monitoring, but due to the time limit, I don't cover them here. So for monitoring, basically at Salesforce, we monitor the different our DNS services from different aspects, like the availability of the name servers and the performance, like RTT. But in this case, I think you're asking for how we can monitor the DNSSEC status for our zones. So basically, we use DNSVs. That is a very helpful tool. So basically, it has two forms. One is there is a public website, dnsvs.net, I believe. So you can type a zone or a record there, and then it will check the DNS status for this zone or record. And then it also output a very, very nice graph. You can see the delegations and all the other information from there. And this DNSVs also have a CLI tool, so you can install it and then run the command line. It also tells you the errors or the status of DNSSEC. So we monitor our DNSSEC zones by using this tool.
Thank you so much, Trey. If there's any more questions, please type in your question in the Q&A or raise your hand in the Zoom.
Thank you, Mr. Han, and thank you for sharing the tool. And yeah, I know the DNS tool. It's very helpful, but before we publish the DNS data in the internet, and I want to test it very carefully the DNS set data before we publish the internet. Yeah, actually, in Vietnam, the domain.vn and cctheory.vn, we have deployed the DNSS for my DNS system. And the question number 2, and I want to ask more questions. Yeah. The question number 2 is I think now the number of domain name or signed DNSSEC is very low. Yeah, and now some applications such as web browser and Google Chrome or Firefox or operator system OS in Windows or Linux, and some resolver is not set for DNSS query, DNSS validation for user. And so do you think we have implementation of DNSS effective up to now?
Yeah, I think so that's more. So that is like the last mile problems. So we have the infrastructure ready and we have all the algorithms ready. So how we can deploy this DNSSEC at the last mile. So I think there's some work to do on maybe on the web browser and OS level, but I think they can configure. They can change their DNS configurations and use the public resolvers like a Google or Cloudflare resolvers, and they all support DNSSEC.
Okay, thank you so much, Han, for answering that question. I am now handing back the mic to Warren for the next speaker. Warren?
Thank you for that, Han and Anna. I'd like to introduce the next person, Edward Lewis from ICANN. He'll be talking about ROA deployment at the top of the DNS in regards to observations of resource public key infrastructure's ROA availability for routes leading to the top level DNS zones, including country code top level domains, generic top level domains, and the reverse map zones. It's showing a snapshot of the deployment, and the repetitions of this activity will illustrate adaptation of the technology. Included in the presentation are other measurements of service aggregation. And I would also like to give a special thank you to Edward, because the time zone, it's actually about 2 a.m. local time where he is at the moment. So if he looks tired, that would be why. And thanks, Edward, for your time. Over to you.
All right, thank you. And I'll get into my talk here quickly because the next person is Champika, and he's a wonderful speaker, and I want to give him some time. This is a talk about ROA deployment. Warren has filled you in on that. Let me get to my. So I look at ROA adoption, and I was going to measure how it's going. I don't intend this to be a cheerleading session for it, but it's helpful to see where it's being deployed and where you might want to push on it if you want to see it go forward. So I have 2 questions to start out with here. What is the DNS core, and what are ROAs? I think some of us may know parts of this. Last time I gave this talk was part of the ROA session, so I've added to that this time around. So first, the core. The core basically is the collection of the DNS at the very top, the root zone, the CCTLDs, the GTLDs, the reverse map I've included this time around, and all of the other zones which are part of the TLDs that we are out there, the sub TLDs like co.uk, for example, subzones. Now, the DNS core, generally, we talk about the registry policy up on top, the registries, the DNSSEC work on top of it. But that's just on top of a whole stack of other services, server hosting, equipment racks, connectivity, and down at the foundation of all this is the routing system. And that's kind of where the ROAs sit. So I think that ROAs and DNS actually kind of go hand in hand. Now, the ROAs in a nutshell are this thing called the route origin, assigning the route origin information. Route origin basically says the route is the IP prefix. All of the addresses in this area follow me, and where you end up is the last hop of the AS number in a BGP route. You take that information, those 2 pieces there, they're the route origin, and you sign it appropriately, and you should be able to trust whether or not that route advertisement at least goes to the right place. And that's kind of what this slide says here. I'm going to skip some of the slides here because they're repeating what I'm saying over the graphics. So I attended a talk in last year, middle of last year. Job Snyder, who's talked a lot about RPKI, came to the registry operators and with an interesting talk, and he said it was RPKI for CCTLD peers. And in his talk, he talked about validating the route information, and it struck me that in the DNS, I think it's important that we protect the routes going into the DNS servers out there. So I looked into that. In the relationship here again is I see DNSSEC as protecting the responses coming back. RPKI and ROA potentially protect, but make sure the data arrives at the registry. And so they kind of go hand in hand. Now, ROA is a relatively new technology. And of course, that's new to the DNS. ROAs have actually been around for quite a while. But the DNS, everything is new. And so it's interesting to look at how it's been deployed. Now, I have a lot of experience with DNSSEC deployment. And whether or not you think it's high or low, the low deployment tells you that it's kind of been a rough road to get this rolled out. High deployment means it was easy. So let's see how that's going. And it's if you really, and also it depends on what you're looking for here. You want to see where it's been deployed because that might help you where you want to focus your energy. Now, my method here is pretty simple. I use a census of the DNS core, a listing of all the elements in there. I look at the zones that are involved, and then look at the name servers that those zones are on. I look at the addresses those name servers use, and then from that I get route information, and I look up and see is that route information covered by a right validated ROA, and you get yes or no. And so everything I have here in percentages are basically this yes counted divided by yes plus no. And then I look for patterns to see where decisions are being made. So all of this lines up to this particular chart, which shows that if I look at everything in the DNS core, that includes what I call 1,778 TLDs. So for those of you who are really watching numbers, that's the 1,500 or so delegations to the root zone, plus the reverse map zones out there, like 12.inter.arpa and so on, 129.inter.arpa and so on, and IPv6. There are 4,000 zones. That's because that TLDs have subzones that they also manage. And all that fits on about 4,000 name servers, which is kind of odd because that's almost the same number of zones, but name servers host many zones out there. Addresses, there are 6,000 or so, 7,000. Roughly there's about 1.5 addresses per name server because there's IPv4 and there's IPv6 generally. But there's only about 3,000 route origins across all of this. There's a lot of commingling, a lot kind of sharing of routes and address and name servers to the system. So looking at all that, I take all the numbers and I find out about 3/4 of the routes involved are not signed by ROA. And that's pretty much the big number here. But frankly, that's not very exciting to hear. So as a person who looks at numbers like this, you always want to go deeper and look at different things. Like, is it more prevalent in V4 than V6? Does it depend more on what kind of zone I have, and so on? So I'm going to dig a little deeper. And we look in here and IPv4 versus V6. This is a traditional split in the routing world. V4 is the old way, V6 is the new way. And we see that between the two of them, the ROA adoption is roughly the same, 22 to 25%. But what shocks me on this slide is actually at the bottom here. This has nothing to do with my talk, but there are at least 18 TLDs out there that don't have IPv6 name servers right now. And I've checked that a few times, and it's true. On the good side, as I've been running these numbers, the account has actually fallen. There were 19 about a week ago. Now we're down to about 18. So slowly making progress on that. But that's not part of this talk. So the next part is I look at the other traditional split. We look in the DNS where we compare the CCTLDs versus the GTLDs, the commercial GTLDs, and the reverse map. And we see across the board that CCTLDs generally have more ROA coverage than the GTLDs. And then there's the reverse map area, which I find interesting because in the reverse map, that's the RARs. And the RARs are really promoting RPKI. And it looks, at the first glance, there's only about half of their routes are covered. But there's kind of digging deeper here is interesting. And I'm going to skip this. I just said that. And if you look at the individual RARs, Afrinic, APNIC, and RIPE, all of their routes are covered by ROA, 100%. LACNIC is mostly covered, but ARIN is a little less than half covered. And when I saw this, I was not so concerned about ARIN's rating or ranking here, but I want to make sure that my methods here were accurate. It was interesting to dig into this. And it turns out, I don't have a slide to say this, but in ARIN, they use roughly about a 10 or 12 addresses for all of their zones. And of the 10 or 12, all but one of them is covered by ROA. The other address, though, has about has about 10 routes to it. It's outsourced somewhere else, and so that, but just by law of numbers, their percentage goes way down. So that helps that. But there's more to this later in the slides too. Now, looking at some of these raw numbers, you don't see really much of a tale about where ROAs are being deployed or not being deployed. You have to realize that DNS registry, the way they're put together, top to bottom, they're very highly layered. And what I said about ARIN is a hint at this. There are many different configurations. There are many different ways that people work with each other. And if someone wants to promote ROA deployment, one thing to do is try to look up and down the stack and see where are the decisions being made. So if I go back to my earlier slide where I had this stack of the elements involved in putting together a DNS service, a registry operations service. On top, there's the registry operator. They generally are worried about what goes into this listing that they're going to put out there on the internet, like who's allowed to have a name in this registry. Is it jurisdictions for CCTLDs, or is it policy for different community types of TLDs out there? Now, a lot of registry operators will also run their DNS, but some of them outsource it to a DNS zone operator, someone completely different who may actually support many registries out there. And that layer will take care of the signing of the zone and putting up the DNS information. And they may do everything also, but they may also outsource this to places that do take care of server hosting. and they get the routing, they got the routing information and connectivity decisions made there. So we have three general places where people make decisions about how they're going to approach the routing. So I look at the first level and I looked at the zones out there and I said, let me rank the zones, whether they're signed or not signed. And I see that I have this chart here, which shows the first 40% of the TLDs ranked from low to high in coverage, they're not signed at all. They're not ROA covered at all. But as you grow slowly to the next 25% or so, there's a steady increase up to those at 100%. Now, this doesn't quite show a clean cutoff here. It suggests that there's actually a wide spectrum of zones that are deployed at different levels of the ROA. So it doesn't seem to be very interesting there to look into. So I came across this other idea. Something I've known too is that a lot of the TLDs out there, we have about 1,500 TLDs that are in the name side and about 200 or 300 on the reverse map side. But a lot of them are run by the same organization, and that's why I call a DNS house. For example, the RARs, there are 5 RARs out there that run all of the 200 or so reverse maps. And on the naming here, there's some very large players or some smaller players. So I went through and I did a little bit of playing with the data that I had available, and I created clumps. And I looked at what was out there. And I came up with this chart here. This chart shows if the dot is at the bottom, that means that the operator doesn't have very many TLDs under management. If the dot's way up on top, that means they have a lot. So big players are way up on top, little players on the bottom. On the left side of this diagram, these are the areas where there's no ROA being used. Oops, I want to use my pen here. There's no ROA being used here. And you see that there's a lot that fall in this column. Over here is 100%. These are the ones that do every route is in there. But in between is a range. It goes from 0 to 100. And it's pretty flat here. And no matter where I am on my chart, I don't see anything that's really telling me much. So I'm not seeing much here. There's interesting other things in there, but not much about this. So finally, I have this chart. And this chart is the AS number, which is what autonomous system number they're using. This is not a ranking in any way, just numerical. It goes from the bottom to the top of the AS number range. And it goes from, again, 0% coverage over here up to 100% coverage. And I'm going to skip ahead a slide because I'm going to annotate these a little bit more deeply because there's something I think it's interesting here. Now, what I did in this chart here, the same chart, and the color codings are here. The green ones up here are the large commercial providers. There's this one here, I believe, is all the same provider, the same organization. They have a range of deployments. They're all kind of low, and they all have these large AS numbers. These are different commercial players out there. Down below here, this box here, this is the older AS space, which is kind of a judgment on my part. They used to only have 16-bit AS numbers. Now we use the whole 32-bit range. So these are kind of the established older ones. And if you start looking at these things, if I start circling things, I notice that this is the zeros. This is 100%. This is the I call it kind of legacy space. And there's not a whole lot of organization in there. And you have this one major commercial player, which is kind of sneaking along here. And there's this one outlier right there. And I think I kind of found something here. There seems to be a divide here about who's doing what. So in the interest of time, I'm going to skip ahead a little bit. And it looks like from this, and I have a punchline here about the RARs. It looks like the decisions to ROA or to ROA over here or not ROA come down to who's doing the routing and not so much who's doing the DNS management up on top. And before I said too that Aaron had a lower rating, these red dots represent the RAR's AS numbers, and all of the RARs fall on the 100% line. The lower ranking, the lower coverage rating that Aaron had earlier is strictly because of one of the AS numbers they use that's over on this side here from one of their commercial providers. So it seems exactly as if the routing decisions are made by the routers and not by the DNS people here. And I do want to point out the orange dot because it's orange. This is an interesting organization to me because they are not a registry or a registrar. They're not part of the domain name system, but it supports so many of them for the purposes of doing routing. And I have noticed that this dot has moved from it was about here when I talked in the fall last year. And I know that they've been trying to not improve, but increase their ROA coverage. And so they are making some progress. So my final points here, measuring the ROA coverage, it looks at the deployment progress. It reveals to me the interactions with management layers. Over time, I would like to look at this stuff. It's interesting to see how it goes. It doesn't change appreciably all that quickly, but maybe over time we'll see how it's going. And the question for many people is, where are decisions being made about deploying or not deploying? It's not so much mandating that we want to go forward, but also finding out why some people don't want to go forward with it, and what are the issues that are holding it back from being fully deployed. And with that, I'm going to finish my my slides and go back to whoever is next. Is it Anna or is it Warren?
Yes, Ed, thank you for presenting and for staying awake. Floor is now open for questions. Just a reminder, to ask a question, you can either raise your hand in Zoom or you can type it in your question in the Q&A. Okay, so if no questions for Ed, oh, we have one. Okay, Ed, this is from Sebastian. Hi, Ed. Sebastian from New Zealand here. Do you have a code to test this?
Yes, I do. In fact, since I was asked by someone whether or not I was going to repeat this measurement, I actually took time to rewrite it all on Thursday and Friday of last week. And it'd be interesting to see if anyone else is able to run what I have. Sebastian, you probably know how to contact me, and we can talk about sharing some stuff and seeing what you want to run.
Any more questions? Oh, okay. Sebastian said he can do a beta test for you, Ed. Any comments on that?
Oh, I'll take it offline with him. We worked over the years, so.
Okay, so I think that's it for the Q&A. I am now giving back the mic to Warren for our next presenter. Warren, over to you.
Thank you, Edward, and thank you, Anna. It was a very interesting presentation. I would be interested in getting a hold of that code too. So our next presenter is Champika Widajaya Thonga. Champika works for ICANN as the Regional Technical Engagement Manager for Asia Pacific. Prior to ICANN, he served as a training unit manager at APNIC and also has several years of experience in the IT industry, academia, research, and training environments. His talk introduces the technical considerations for configuring and supporting the email address internationalization. Over to you, Champika.
Hello, everyone. I hope you can hear me and you can see me as well, and my slides too.
Yes, Champ, we can hear you and see you.
All right, thank you, Anna. So yeah, my presentation is going to be on supporting internationalized email addresses. And thanks very much for APNIC for giving this opportunity. And it's always a pleasure to be at the APNIC meeting, at least this time as a remote participant. And so before we really get into the internationalized email addresses, I just want to quickly touch on the universal acceptance, or pretty much what we call UA. And so here, the vision of UA is to make sure that all domain names and the email addresses work on all applications. Now, when we speak of UA or the UA readiness, pretty much, we need to consider two aspects. One is on domain names, and the other one is on internationalized email addresses, or EAI. Now, when we speak of domain names, as we all know, from historically, we have been used to 3-character top-level domains, or TLDs. But since number of years, since like 2012 or so, we have had new generic top-level domains, or what we call new TLDs. And then these new TLDs also consist of some of the longer top-level domains as well. So there are some examples shown in the slide. For example, this one, example.sky, is a newer top-level domain, whereas if you consider example.melbourne, that is a longer top-level domain. Now, there are also actually internationalized domains as well, or simply what we call IDNs. Now, the next domain, what you see here, which is written in Chinese scripts, characters, that is an IDN. In case if someone is new to IDN or EAI, I hope that's clear enough to define the internationalized domain names. Now, when it comes to the EAI, or internationalized email addresses, again, there are a few forms we may need to consider here. First is obviously where your mailbox is an ASCII-based mailbox, and whereas the domain is an IDN. So this example is something similar, where mark is your ASCII mailbox, whereas society with the accent of those characters, that's an internationalized domain name. And then also we see some of the email IDs where you have Unicode-based mailboxes on your left, and then where you can have ASCII-based domains, as well as Unicode-based mailboxes and IDN-based domains. And also actually, most of these scripts, of course, we write from left to right, like English, for example. But there are also some scripts, some languages where we write from right to left, for example, like Arabic. So if you consider the last example here, that is an Arabic email ID where we write from right to left. So basically, your mailbox is in the right side, whereas the domain is in the left side. Now, here the important thing is when we say UA ready, we have to make sure these internationalized domain names, as well as all those newer top-level domains and the longer ones, as well as all those email IDs, what we discussed, they're all properly accepted in applications and then validated, processed, and if it's been stored in databases and things like that, they can be stored properly. And then also it can be displayed properly as well. Say, for example, if you try to register for a certain website, web form, for example, and if you are giving your email ID, say as an EAI, we have to make sure that form, the application, can accept those email IDs and process it properly, and then also store it properly and display and so on. So this is what we are trying to achieve in universal acceptance. So this now, we have also actually done some measurements in this regard, just to actually see how different websites are actually UA ready. There have been some considerations for around 1,000 or so top websites in the world. And you can see that most of these websites actually do not support, especially the internationalized email addresses. Actually, you can see especially when you have a EAI, basically mailbox, it's pretty much less than 10% or so. Whereas when it comes to ASCII-based mailboxes, especially and then the IDN-based domains, it is much better than Unicode-based mailboxes. Still, the figures are going into like 80–90% or so. Over the years, from like 2017, these measurements have been taken. over the years, we see there is some improvement, but still it is not really 100%, just like ASCII email IDs. This is also, again, a different view here. This is actually EAI support, especially in TLDs based on the mail servers. So if you consider the MX records, see whether those mail servers do support EAI. You can see actually, when you consider all the TLDs, pretty much, less than 10% or so were EAI ready. So this clearly says actually there has to be some work done, especially in terms of supporting EAI. So that leads into my talk related to the EAI, or the email address internationalization. Now, there are some prerequisites actually in terms of setting up EAI. Now, especially when you type, say, your local scripts in the keyboard, or what we say, where we represent certain glyphs or different local language characters, that has to be represented or encoded. And we use the encoding UTF-8 encoding here, as probably as you may know, in the past we used to have ASCII-based encoding, and but for English type of characters, that's all fine, because you can have 127 characters, and that includes all the English alphabets, and then plus the other number of other characters as well. But when it comes to especially local language scripts, definitely we need more bits out there, more than 8 bits or so, and also more than 127 characters. That is why actually there are different encoding schemes where you have things like UTF-8, UTF-16, UTF-32, and so on. But based on several factors like processing, storing, and transmitting, and so on, the most optimal encoding scheme has been the UTF-8 here. So that is why actually we will have to do the processing based on UTF-8, or what we call Unicode Transformation Format. Now, we need to do something called normalization. So that is basically, say, if you are representing a certain glyph. So in this case, consider this letter, small e with a little accent. There is a certain Unicode code point. So that is actually represented with U plus 00E8, which is in hexadecimals. So this is the code point for that E with the accent. Now, the same glyph can also be represented using two key sequences here, like small e plus the accent. So someone can use that as well. So that consists of two other code points, which is 0065 and 0300. So the thing is that we have to actually unify, basically we have to normalize this, and to make sure that it is represented in one way. So this is what we call normalizing, and that has to be done in the application. So, and then there are other considerations here as well, things like when you represent these IDN labels, you have to support both what we call U labels and A labels. U labels are based on the Unicode. So in this case, example, where you have a certain local language script here, glyph here. So that is actually based on Unicode, whereas this needs to be actually represented in what we call A label. So this one is an A label where you have ASCII-based representation. Now all the A labels will have something called XN hyphen, which is actually coming in the front. In fact, this is also what we call a puny code. So, so we have these representations. And so all this actually defined in this standard called IDNA 2008. So internationalized domain names in applications, that's the standard, IDNA 2008. There have been a previous standard as well, which is IDNA 2003 standard. But that is also, we should always refer to the IDNA 2008 standard. Now, in some of the applications, especially if you're a developer and so on, when you do your development work, sometimes you may have to use these TLDs, especially for parsing and so on. So one of the recommendation is that do not use any static TLD lists here, because the top level domains can always change. It is pretty much dynamic. So for example, tomorrow a new TLD can be added, and so on. So currently there are over 1,500 or so TLDs, and we should always refer to these dynamic lists rather than statics. So IANA maintains a list of TLDs. We should refer to that. Now, sometimes, when you also do some parsing, we should not actually use regular expression because it can be a bit complicated. It's always good to use IDNA 2008 libraries in this case. Now, when it comes to the email protocol changes for EAI, because as we know, we use SMTP to send emails between mail transfer agents. So between MTAs, we have to make sure that the SMTP is augmented to support the EAI. And so this is done with a signaling flag, what we call SMTP UTF-8. So we have to make sure that all the mail servers can support EAI, and you have this flag SMTP UTF-8. So the other important consideration is that when we send the email, all those mail servers in the path should also support EAI as well. Also now, considering the mail delivery agents like POP and IMAP, so they should also support EAI as well. So that is, there are some flags even to support the EAI in POP and IMAP servers as well. So this is actually just an example to show what we discussed earlier. So here you can see there's a sender, there's a receiver here, and then in between you have number of MTAs for demonstration purposes here. And between those mail servers, mail transfer agents, we have this SMTP protocol. And when these mail MTAs talk to each other, there are certain signaling happens between them. And then one important thing to note here is that you can see that the receiver is responding that it can support SMTP UTF-8 here. So once the sender gets that acknowledgement, it can start sending these EAI-based email addresses, actually. And then the mail headers and the messages can be sent.
Sorry, Champ, I have to interrupt you because we only have 2 minutes left for the session.
All right. Okay. Yeah, I'm pretty much going into the end. Yeah. So, and then there are a couple of considerations in the delivery path considerations. Just make sure that all the mail servers, MTAs, plus the mail submission agents and the delivery agents can also support EAI. That is important. And then in case if, say, in between, if any mail server doesn't support EAI, then the mail server has to make sure that it sends it drops the message, of course, but then sends a delivery message to the sender, basically. There are a couple of other considerations here. Case folding is not really automatic. In general, ASCII-based emails, we use, whether you write small case or uppercase, it doesn't really make much of a difference. But in the case of EAI, it makes a difference. So automatically, the EAI ready software doesn't support that. In terms of spam, we should still go ahead with things like, SPF, DKIM, and so on. But sometimes we need to be careful because some of the spam filters may, look at the body, email body, and if it sees some local language characters, then it might actually consider it as a spam. So I think, especially if there are some developers considering spam filters and so on, they should consider this aspect as well. In terms of software services, currently not every client server software actually doesn't support EAI. So this is something that I think we should consider, especially, the whole highlight of this presentation is also to create some awareness here and to make sure that we support EAI in our systems here, in this case, particularly in mail servers. Now, there is a website here, which is uasg.tech. There are a lot of resources. There are a lot of white papers and documentations, presentations, and so on. I would recommend you to read those. And there are also actually some URLs here. Yeah, you can actually visit those for your further reference. And in case if there are some questions, there are some email IDs here as well. But if there are some questions, I can take maybe some questions. But feel free to contact me if you have some further questions as well. Thank you.
Okay. Thank you, Champika. We do have one question in the Q&A. This one is from Karan. Any unique challenge of setting up for the right to left parsing languages?
Yeah, actually, of course, there have been a lot of challenges. In fact, not only the right to left, but also even from both aspects as well, especially when it comes to the IDNs and EAI based systems. So that is why actually, in fact, if you go to that UASG website, there are a lot of these case studies. I would recommend you to actually refer to those. So in those case studies, many of those challenges and scenarios have been described, I would say.
Okay, that's all. Thank you so much, Champika.
Yeah, thank you very much, Anna. Thank you. And thank you all.
For the rest of the other questions, I'm going to have to ask you to send them at conference@apnic.net, and we'll send them to the speaker for you.
Thank you.
Thanks again to our presenters, Han, Ed, and Champika, and of course, Warren, for moderating the session. I'd like to invite you to participate in the poll survey for this session. And this is the end of technical session 2. And while taking your break, you can join us in the social space, which is available in the conference program. See you in the next session.